All right, welcome everybody. Today we're going to be talking about how to find those things that we've been finding with vertex form equations. We're going to be talking about how to find them using standard form equations. We don't want to have to try to convert every standard form equation we find into vertex form, especially when they're kind of gross. Okay, so my question to you is, where is the axis of symmetry? Take a second, pause the video, put your finger where you think the axis of symmetry is for this generic random quadratic graph. Okay, you found the axis of symmetry. Hopefully you found, let's see if I can actually draw it. Hopefully you found that it's like right about here. Okay? Now, my question to you would be, how can we find that? How can we find that without having a vertex form equation, without knowing where the vertex is? So, how can you find the zeros of any quadratic function you'll ever come across? So just really quick, remember that the zeros are the solutions of those quadratic equations, or where it crosses the x-axis. How can you find the zeros of any quadratic equation you'll ever come across? Take a second to pause the video and think about that, and see if you can come up with some sort of response. How can you find the zeros of any quadratic function you will ever come across ever in life? Okay, take a second, pause the video. Okay, hopefully you were able to come up with the quadratic formula. The quadratic formula. This guy, all right? Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we can say with certainty that if we are subtracting whatever this value is, then we're going to get the smaller version. If we're adding whatever the value this is, we're going to get this larger of the two zeros. Okay? So that's where these two numbers come from. This is negative b minus the square root of b squared minus the square root of b squared minus 4ac, and this is negative b plus the square root of b squared minus 4ac all over 2a. Okay? So, how far are each of these things from the axis of symmetry? How far are each of these points from the axis of symmetry? Well, our axis of symmetry is going to be halfway between them. So if we take those two values, those two x values, and add them together, and then divide it in half, we get halfway between them. We get that midpoint value. So let's take a look and see what that looks like. So if we combine like terms across the top, we're going to get negative b minus the square root of b squared minus 4ac. Because this denominator right here is the same as this denominator right here, I'm going to go ahead and just add those two fractions together. So plus negative b plus the square root of b squared minus 4ac. That whole thing is over 2a. And that is then divided by 2, because we're cutting that in half. We're finding the average of those 2 points. So from there, let's continue cleaning up the top. This is starting to look pretty gross, but that's okay. It's going to get better, I promise. Well, this right here is a negative square root of some stuff, and this is a positive square root of that same stuff. So these are actually just going to cancel each other out. So then we have negative b plus negative b. Well, that's negative 2b over 2a over 2. See, it got a lot nicer, I promised. I told you it would happen, and it did. So here we have 2 over 2, so those 2's are going to reduce out. And then if you have, so then we're going to be left with negative b over a over 2. So if we're dividing this fraction by 2, it's the same as multiplying that fraction by 1/2. In this case, we get negative b over 2a. So this is the x value of our axis of symmetry. This is our axis of symmetry. Axis of symmetry is going to be x equals whatever b and a and c are, negative b over 2a. Okay? So, keep this idea in mind. So our axis of symmetry is equal to negative b over 2a. So, whenever we take our vertex, in order to find our vertex, whatever value we find for our axis of symmetry, we are going to plug that. We generally have f of x equals some stuff, right? We are going to then evaluate that at f of whatever value we find for our axis of symmetry. Okay? Whatever value we find here is our y component of our vertex. Whatever value we find when we plug in the value of our axis of symmetry into f is our y value of our axis of symmetry. So, I would recommend pausing the video before I start talking about each of these things, so that way you can just write all this stuff down, and then, once you're done writing all this stuff down, restart the video, and then follow along with what I'm saying. Okay, go ahead and pause the video. And, so this is what we were just talking about for our vertex. Our vertex is always going to be of the form, whenever we have a standard form quadratic, it's always going to be whatever b is, divided by 2 times whatever a is our x component of our vertex, and then our y component is this function evaluated at whatever that number is. Okay, we'll see a concrete example of that here in a second. But we take that number, whatever we find for this, plug it into our equation wherever we see an x, solve this thing for that number, and that is our y component. Our axis of symmetry is the x component of our vertex, or negative b over 2 times a, if we're in a standard form equation. And then we have a maximum and a minimum. Up until now, we've just looked to see if it is a maximum or if it is a minimum. But now we can start talking about, well, what is the maximum x value? Or what is the maximum y value? Or what is the minimum y value? So the y value that is our maximum is our function, or our function evaluated at our axis of symmetry, or the y component of our vertex. So whatever number is here is either our maximum or our minimum, depending on whether a is positive or negative. That is our maximum or minimum value. Okay. So what I would like to do is let's find the vertex, the maximum and the minimum, the range, and the intervals over which this function is increasing or decreasing. We'll talk about this later. We want to find all these. So give yourself a second, and using the information from this page, using the information from here that you all just jotted down, go ahead and find axis of symmetry, vertex, and then whether it's a maximum or a minimum. And then what is that maximum or minimum value? Okay, go ahead and I'm going to give you a chance to pause the video and then take a look and see if you were able to come up with the same thing I did. Okay, so in order to solve this, we have negative b over 2a. So we have negative 14 over 2 times negative 1, which is negative 14 over negative 2, which is 7. So this is our axis of symmetry. Axis of symmetry is equal to 7. So if we plug in 7 into this equation, so if we plug in 7 wherever we see an x, plug in 7 here, we get that f of 7 is equal to negative 7 squared, and remember we're squaring just 7 and then making it negative, plus 14 times 7 minus 47. All right, so then we have that is equal to negative 49 plus, let's see, 14 times 7 is 70 plus 28, so 98. 98 minus 47. So let's see, so we have 49, 98, let's see, that is 80, 86, so I think this is 2. I think this is true, I think this is 2. Seems reasonable. 49, 47 is 96, yeah. So, our f of 7, our function evaluated at the axis of symmetry, is 2. This is our y value. So our vertex is at the point, whoopsie daisies, I messed up, guys. Hopefully you caught it and you were like, Mr. Seja did a silly. X equals 7. That's my bad. Okay, so then our vertex is at 7, 2. I don't know why you guys sound like that in my head, but that's the voice I gave you today, so deal with it. Deal with it and move on. Our vertex is at the point 7, 2. Okay? So then we need to determine whether this is a maximum or a minimum. And because this guy right here is negative, this is a maximum. maximum, and our maximum value is at y equals 2. So that's the top of our graph. It will open downwards. Okay? So here is all of that information again. Maximum, we do have a maximum at x at y equals 2. Okay? We have a maximum at y equals 2. So if we were to graph it, we would have the vertex would be at the point 7,2, and everything would go down from there. Okay? So last thing we want to talk about today is increasing and decreasing. So we want to determine the intervals over which a quadratic function increases or decreases. Okay? So when we think about that, we have to determine whether it has a maximum or a minimum. It's always going to have the form negative infinity, comma, axis of symmetry, and then so it's going to go from negative infinity to our axis of symmetry, and then it's going to go from our axis of symmetry to infinity. Notice how we don't include infinity, or we'd have a square bracket, and we don't include our axis of symmetry, again, or we'd have a square bracket. All right, we can't include infinity because it's not a number, it's just a concept. So it's a curved bracket. And we don't include our axis of symmetry because at our axis of symmetry, our graph is neither increasing nor decreasing. So, for example, if we have a graph that looks like this, okay? So let's say we have our axis of symmetry is at, let's say this is x equals, well, like on our last one, x equals 7, okay? X equals 7, that's our axis of symmetry. We want to find out whether it is what it's doing. So we'll say negative infinity to 7, and then from 7 to positive infinity. Okay? So we're always moving left to right when we're talking about increasing or decreasing. So if we look at our graph, as we're moving from left to right, it's starting down here, and then as we move left to right, it's going upwards. It's increasing. And then, after x equals 7, it then turns and starts going downwards, or decreasing. So we can say that this function is increasing over the interval negative infinity to 7, and then it's also decreasing over the interval 7 to infinity. Okay? So that's how increasing and decreasing works. So if we were to, let's see if I can do this. Good luck to me. If we have this same sort of graph and we give it the old rotato potato, and we still have our vertex at x equals 7, we would have the exact same, it would look exactly the same, except it would now be decreasing from negative infinity to 7 and increasing from 7 to positive infinity. Because as we're going from left to right, we go down, we're decreasing, and then after we hit the vertex, that axis of symmetry, we then go back up and we start beginning to increase. Okay? So, believe it or not, that is all I have for you today. All right, today's a pretty short day, so go ahead and hop on to Google Classroom and start taking a look at the assignment for tonight. Give it a shot. Your goal is to essentially do what we just did. Use those ideas, figure out where things are, where the axis of symmetry is, where the vertex is, whether it's a maximum or minimum, what that maximum or minimum value is, and then also give me the intervals over which it increases or decreases. Okay? Hope that was a enjoyable video for you. I will see you guys tomorrow. Have a wonderful, wonderful, wonderful day. Or I might see you later today if you're out and about. Okay? I'll see you guys later. Bye.